Okay. All right, so I'd like to welcome everybody to Context is Critical. This is K through kindergarten through 5th grade math 3-act math tests. And I'm happy that you're here today, not only because you made it past lunch and we're back, but also we're going to talk today about some things that are really important in terms of math education. This morning, I was able to host 2 different sessions that really looked at K2 mathematics, and we talked a lot about what it means to be a mathematician instead of being in a math class. And there is a difference between the two. And what we're going to explore today with looking at 3-act math tasks does a great job of reinforcing that. We know that for years, the words like inquiry-based learning, real-world math applications have been thrown around. And the overall gist of it is that we do want students doing things that apply to the real world. We want them being problem solvers. We want them being efficient in mathematics. We want them being able to look at a mathematical scenario and approach it with flexibility and being able to find multiple ways to look at that and arrive at a solution. And so that is really where we're going to go with this today, thinking about what real world means in terms of mathematics, how that phrase is often overused and misunderstood. And we're going to look at a great instructional resource that's available for you to use that really supports students developing as mathematicians and reinforcing that idea of what mathematicians do. So we're going to get started today, as always, with all the sessions that we've had previous to this and in our last session. Everything that you see here today is available to be downloaded. All of the images, the videos that we go through, there's a write-up of the actual lesson that can be downloaded as well. So I'll make sure at the end to kind of show you where you can find all of those different things. So we're going to start off with a 3-act math task by doing a 3-act math task. I'll preface you, so this is a kindergarten through 5th grade session. I try to go like middle of the road, but at the after this, we'll take a look at what this looks like in a kindergarten classroom because those mathematicians tend to be more in their math infancy, so they require additional sets of support. And then you'll be able to see kind of what this looks like at a higher scale with like a 5th grade classroom. So for the first act of our 3-act math test, I am going to show you a video. And in this video, I am interested in 2 things. I'm going to ask you 2 questions. What do you notice? And what do you wonder? It's not a long video, but I am really primarily interested in these 2 questions. So keep this in mind as you watch, and then what we will do is share the information in the chat. So what do you notice and what do you wonder? All right, that's it. So take a thing. Let's start off first with what did you notice? So what are some of the observations that you made while watching that video? What did you notice? Okay, so Chris is wondering how many bags did it take to fill the jar? Good, Krista, we're going to come back to that thought in just a minute. And it's good to see you again. All right, they filled the jar with a fun-sized bag of Skittles. So you noticed that first there was a jar that they were filling, and you noticed the size of the bag, which many kids would be able to identify that was a fun-sized bag, not a king, but a fun-sized bag. They use small bags. Okay, good. So Desiree said they use small bags. And by bags, I think you mean that they use more than one bag. That would be an important observation. They filled the jar. So Krista said they filled the jar. You notice at the end, he kind of like tapped it, screwed on the lid, so it was completely filled up. They used original Skittles, excellent. So not like the Easter ones or like some of the like really tropical fancy ones. They were like the good old original rainbow Skittles. Excellent observation. Many students would observe that. I noticed that candy was filling the jar. All right, good. So, all right, let's start with some of the wonders. I wonder if we will get to eat them. Good question, Kim. Many kids would also wonder the same. What are some of the things that you are wondering? I know Krista said she started off with how many bags did it take to fill the jar? Will we get to eat them? Let's see, what else? How many bags did it take to fill the jar? That's a good question. How many Skittles are in each fun-sized bag? There's a lot of great ones. How many Skittles are in the jar? Very nice job. Okay. All right, so these are all questions that I would come to expect from if I was to do this with fourth graders. I would expect that they would, well, first of all, looking at the noticings, Desiree's worried about just the efficiency of this. Why would you not have used a bigger bag if you have that size of a jar? Also a great question. So when we think about the noticings, the observations that they made, I would expect a fourth grader to say that it was the original set of Skittles. It was a clear jar. They filled it to the top. Then some of the wonderings, how many Skittles were in the jar? How many bags did they use? How many Skittles are in a bag? How many are red? Oh, I like that, Rich. So really thinking about some of the more, you know, smaller details of how many are red. Good. Okay. Well, these are a great list of questions. For today, we don't have time to answer all of them, but there was one question that came up multiple times. And I would assume that if we had a larger sample size here, more participants, that the question of how many Skittles are in the jar would probably be one of the most common questions. So we're going to take a look at this question today. The main question that we want to answer in this mathematical investigation is how many Skittles are in the jar. So that's what we'll go after. If we have more time, we can try to answer some of those other questions that you felt were important, because we always want to acknowledge that. But for right now, we're going to answer the question, how many Skittles are in the jar? We're going to start off by making an estimate. Now, as an instructional, just simple everyday math skill, estimates need to become more popular. Estimates are cheap and easy and anyone can make them. We do predictions all the time in science, but we don't do a lot of estimating in math. And when we think about how estimation relates to number sense and just being able to reason with mathematics, estimating is really important. So we're going to estimate here, and I'm going to show you a scale. And I like this scale for a variety of reasons. But if you were to take this scale and you were to estimate how many Skittles are in the jar, I first want you to come up with two numbers. A too low estimate. There is no way this few Skittles are in that jar. And then a too high estimate. There is no way this many Skittles are in that jar. And what we're doing right now, it's called Goldilocks guessing. So we're thinking of a too low, a too high, and then once you have those benchmarks, I'd like you to determine your exact estimate. What do you think are the exact number of Skittles that are in that jar? So a too low, a too high, in the exact number. Good question, Rich. All right. Okay, now all of you have a number, and I'm going to ask you to kind of share out what that exact number is, but only within a frame of kind of like a range. All right, so I'm going to send out a poll right now, and I am interested in how many Skittles are in the jar. So the number that you came up with, that is your exact estimate, right? Go ahead and select what range that is in between. So are we between like 0 to 200, 201 to 400, so on and so forth. And I like doing this with students because it immediately engages them in the problem. They've made an investment now. They have put down their name to a number and they're in it. And we could say, well, yeah, but now if they are wrong, won't that make them feel bad? But it's okay, if they're wrong, they have loser friends that are along with them. All right, so I see some 200 to 400. That seems to be the most popular. 401 to 600 and 800 to 1,000. Ooh, very good. So some smaller, and it's hard. When you're doing it virtually, you can't really tell how big that jar was. But these I would say are all reasonable estimates. Very nice. Okay, good. So I want you to keep this because this is important. When we ask students to make estimates, we can then reference back to them to see if we think our answer is reasonable. If we don't make an estimate, we get an answer and we're like, okay, well, I guess that's it. I don't really know how reasonable that is. So keep that in front of you. All right, so that's some important work we did. Now for Act 2, I'm interested to know what information would you want in order to solve this problem? So what questions would you like to ask me in order to determine how many Skittles are in that jar? All right, how many Skittles are in a fun-sized bag? How many bags did they use? Excellent. Any other questions you would like to ask me? How many bags? Okay, good, common question. All right, good. So these are important questions because this information allows us to start working towards answering this question in some sort of way. So one of the questions that you asked me was how many bags are there? This was the number of bags. Here you go. How many bags do you think that is? Let's estimate. That many fun size Skittles bags. What are you thinking in that pile? This had to have happened like after Halloween. I want to go ahead and estimate. All right. Well, your estimates would probably be, I don't know, maybe all over the place. They may be more centered towards, I don't know, what would you say, like 40, somewhere around there. I mean, that pile seems pretty high. Krista says 40. Okay, good. So we have kind of a baseline. Some people may say, no, that's too many, that's too few. 40, 45, 50, 30 to 50. Okay, good. So there's a range. Well, I mean, you guys are pretty good. All right. When we look at this, it tells us that there are exactly 58 packages, fun-size Skittles in that jar. 58 packages. All right, so that was one of the things that you asked me about. The next piece of information that you wanted to know was how many Skittles are in a bag. So in this particular bag that we sampled, right, you can see right there that it's kind of like laid out there for you, all right? There are 14 Skittles in the bag. 14 Skittles in this bag. Okay, those were the only two things you needed. You must have some kind of plan on how to solve this problem of how many Skittles are in the jar. So what I'm going to ask you to do right now is go ahead and solve. Now, if we were doing this in a classroom, we would open this up to kids, solve the problem. We know there are lots of ways to do multiplication problems. And in fact, in this particular example that we're doing, the standard, I'm going to read it word for word, says illustrate and explain the calculation by using questions, rectangular arrays, and or area models. So I'm going to encourage you to solve this problem one way and then try a second way to solve it. All right, so try more than one method. And because we're all adults and not fourth graders, this shouldn't take us too long. All right, so whenever you are ready, I would like you to go ahead and share your answer and the method that you use to solve in the chat. Okay, now if we were in person doing this, I would do it by groups and have groups with the chart paper and showing each of the different ways that they solved this problem, just for how you would expect this virtual versus in person. So not as good of a visual in terms of the PD here, but if you would go ahead and share what you got and then how you solved it. 812 using a standard algorithm area model. Okay, standard algorithm and area model, good. All right, 58 times 14 using standard algorithm, good. 732 broke apart 58 times 10 and then 58 times 4 and added them together. All right. Okay, excellent. So a couple of different ways to do this. Oh, a calculator. Well, Amanda, you are on your phone, so I would expect that. So that's good. I'm using a calculator, good. Oh, 870, a tape diagram, okay. It's all right, Krista, it's Friday and it's after lunch. All right, nice job. No one put down that they used like an array, but that's okay. I wouldn't expect to see you hand draw out 54 groups or 58 groups for 14. But that would be another way to do it. So lots of different ways that we can have students do this. But what I'm seeing here is that the common answer is 812. Now, my question to you before we take a look at the solution is that a reasonable answer? So if you go back to your estimate, does that fall between your lowest number and your highest number? And if it does, that's probably a good sign. If it doesn't, that might mean that we either don't trust our mathematics or perhaps we don't trust the model that we used, right? And this would be a great time to either go back and check our math, or perhaps we need to check and rethink if what was reasonable in the first place. Okay, so here we go. For Act 3, we're going to take a look at the solution. All right, so 812 was what we were going with. Before I play this, does anyone want to put like a side note into the chat? Anything that you're thinking about your solution that you got 812, but you might not be happy with it? Okay, so Krista says there might be more or less in each bag. Interesting. So it's not guaranteed that you have 14 Skittles in each fun size bag. All right, nice job. Okay, that is very true. So knowing that, let's take a look and see what happens. All right, so this is the image that we are left with, and he very clearly says at the end, the answer is not 812, okay? So the answer, if we take a look at this array and we kind of put it all together, is we end up with 853 Skittles, right? Oh, Rich, that's interesting. I figured bags would have a different number. I used 15. I wonder if that's like, you figured that would be an average, maybe? Maybe you have a lot of experience with fun size Skittle bags and you've counted them all before. That is, you know, looking at averages would definitely impact that. But yes, so the answer here is 853. And we find that really interesting because it is not exactly what we got. And then for students at this grade level to talk about, well, what could be the reason for the variety and or the different answer that we got, what could possibly account for that, okay? Now, when we get to Act 3, the answer doesn't stop with just the solution, okay? So some other things that we could take a look at is, you know, what other questions could we investigate? So looking at this, you also had questions that were in the beginning. I think one of the questions was like, how many red M&Ms are there? It would be a great experiment to try to figure out how could we determine that. on average, how many red M&Ms would be in that. There was also a question about percentages. So even this 4th grade example really could be done with students at a higher level of mathematics. It just depends on what question you want to ask them. Okay. So other questions that students could investigate from this, any ideas? Well, I think those examples that we kind of talked about in the beginning with like percentages, the number of bags, what would be interesting is if a lot of you asked the question, well, why didn't he, okay, graphing the amount of each color, so then taking it to another step and looking at a different piece of mathematics with arranging it in a graphical representation of some type would be great. Good idea, Desiree. And yeah, so we can go through and we can look at a variety of different things. One of the suggestions or questions you had is why didn't he use a larger bag of Skittles? Maybe we could see how that would change. Would it still be equal to about 853 if we used larger bags of Skittles? Or would that create a different solution? So there's lots of different things that we can kind of take a look at here. But this is an example of a 3-act math task. And we'll go through each of those acts and kind of what they exactly covered and what steps the students take in each of them here in a second. But I want to go back to our initial point of this whole conversation, which is looking at the mathematics and that real world context and experiences that the students have. So I want you to take a minute to consider these 2 examples. The example on the left, which shows you an image of the Skittles, where we started in Act 1, shows that entire process. So think about what you just experienced as not only an educator, but through the lens of your students, what that might look like. And then on the right, this is a typical worksheet or sample from a textbook that would cover essentially the same concept, the same standard. And I want you to think about this in terms of how the problems differ. So first, I'm going to ask you to think about how does this differ for this student? What is different that the student is experiencing in the 3-act math task versus what they would do through the worksheet or through the textbook? And you can go ahead and throw that into the chat, or feel free to unmute yourself as well. It's, you know, I'm not worried about everybody talking over themselves, so. Okay, it's much more engaging. Krista, can you elaborate on that? So I'm assuming it's engaging for the student.
Yeah, I'm just thinking that it's more engaging for the student. They have more buy-in. They have more, like, they're more involved with it rather than just solving the problem.
Excellent.
There's more steps to it.
Good. All right, any other thoughts on the student experience? Maybe consider why are, like, how are they what are they doing that's different than in the textbook problem or on the worksheet?
There was a lot more questioning that they had to do.
All right, excellent. So when we think about these 2 problems, the very first thing that happened when we watched this video is students were given the opportunity to not only notice things, but it started off with what they were wondering. So before they were really given any kind of mathematics or text or diagrams or directions or procedures, they were allowed to just think of what questions they have in their own mind. Good, so Kim said, I think that they have more of an opportunity to think about it out before, during, and after. All right, nice, excellent. So in terms of the student experience, what we usually say is 3-act math tasks are a high floor, low ceiling problem. They are a problem that is it's not intimidating for students. There's no text. For our students that are ELL students, or students that struggle or are with reading or literacy, there is no text there to stop them. They are immediately engaged in something that is interesting to them. It initiates questions about what is happening, and anyone can do it. Anyone can look at a video and come up with a problem. So in terms of the student experience, it is much richer and less intimidating than looking at a worksheet. When, again, we think about what a mathematician does, a mathematician looks at an example in a real world and is able to pull those things out, ask questions about it, search for information, make observations. In math class, that's a worksheet. Mathematicians don't typically sit down, follow a procedure, and fill out a diagram that's half provided for them already. So this really supports what a mathematician does. The next question that I have for you, we're going to skip over to the other side, is how this promotes inquiry. And the reason I'm asking you about inquiry, we talked about it at the beginning with it's a high frequency word in education, that it's inquiry based. But really thinking about what inquiry is, we also know that inquiry is based a lot on student direction and where students go with their learning. And when you start off a problem with questions that are student generated, even though I had a problem or a question I really had in mind that I wanted you to work on, usually when you do these with kids, the question that you have in mind or the goal of that question, students immediately go to, but it's considered their idea because they're the ones that ask that question. So it's inquiry based because the 3-act math test, it's all based on questions. The initial problem was a question, and the information that you sought out were both questions. You asked the question of what information do I need and told me exactly what that was. When we look at the worksheet, there are hardly any questions on there. It is a procedure written for us that requires just procedural learning, procedural expectations of going from one step to another. And it even tells us exactly how to solve that problem using an area model and then using partial products. So even without the opportunity to really think about a way to solve that problem or a strategy, which obviously with the 3-act math task, there were a variety of different strategies that you use and that students can use. And although we do want students becoming familiar and comfortable working with things like standard algorithms and partial products, area models, we also want them being comfortable enough to choose what model they want to use to represent the learning or represent the mathematics. And that brings us to the last one. And this is where sometimes the debate gets a little heated, but it won't virtually. Which one is more real world? I'm going to ask you to really put your answers in the chat because I'm very interested in this. Which one of these is more real world? When we talk about real world math, which one is real world? Okay, putting the Skittles in the jar or looking at the scenario that's in the other with keeping track of the canned food from the canned food drive. You can put that into the chat. And if you could write your justification, that earns you bonus points. All right, so Krista had an answer here that says the Skittles in the jar, she would say is more real world. And her justification was because you had to use your own thinking. Desiree said that perhaps the canned food drive was more real world because students have experienced that. There's a lot of schools that do canned food drives or community organizations that do those. Kim said Skittles in the jar because it's tangible. And I'm assuming, Kim, you mean like you can touch it. The students could actually pour this bags of Skittles into the jar. Excellent. And you know what, these are, Skittles is more real world. If they saw something similar, they would wonder the same thing. Okay, good, excellent. Well, everyone has great points. And this is where the debate over what is real world becomes a little more hazy. So when we think about real world applications, it is very common to think that we give students real world experiences in mathematics by connecting them to either what students are interested in or what students experience in their everyday life. And I did this when I was in the middle school classroom. I taught 6th, 7th, and 8th grade math for 7 years. And I would make a very serious effort at making sure that the examples that I provided the kids were written within the context of what they were interested in. Cell phones, football, monster drinks, that was always a big one. Anything that they were interested in at the time, I made math problems about. And what I noticed is that sometimes it would hook kids and sometimes it wouldn't. And what's interesting about that is some research has been done on that. And I want to share with you a book that was written that kind of talks about that. And Daniel Willingham, who wrote a book called Why Don't Students Like School? And what he came up with, which actually makes a lot of sense, is that we use contexts like sports and shopping or drinks or cell phones or whatever kids are interested in, and we put a math problem into it. But what he says is that a lot of times the mathematics itself deter from that actual context. Students don't really even care, or they don't see the value in that. And when we think about the real world part of that, that actually also makes sense, that perhaps real world isn't about what students actually see in the real world, but it is what they are doing that makes real world math applicable to them. So think, for example, a 56-year-old male, his real world is very different than what an 8-year-old's real world is, and what their life experiences are, and the context in which you can take parts of their lives and apply it to math problems. And that's really what we look at here. So I'd encourage you to think about when we talk about real world math and writing math in real world context, to think about what students are doing that make it real world. 3-act math tasks were created by a wonderful, I'm sure you're familiar with him if you really have done PD in the last, I don't know, 15 years. Dan Meyer is a fantastic resource for math educators, and he came up with this whole idea of 3-act math tasks before they were sold to like Pearson and all the other math curriculum sites. But here's his definition of real world math, and I think that this is really important. It's not to be lost that the math that you ground or the context you ground your math problems in doesn't matter, because that would not be true. But what we're asking kids, we want kids to do mathematics and to really start applying that questioning and that estimating. So he says if you can ask questions about it, it's in your real world. If you can guess about it, it's in your real world. And if you're able to argue about it, it's in your real world. And I think that this is a great quote, because it is exactly what we want our kids doing in class as mathematicians. We want them asking questions, we want them estimating, and we want them proving. We want them to talk about how they got their answer, why they know it's correct, or what they may have done wrong. So keep that in mind as you're going through and you're kind of really thinking about what real world math looks like. We also know that this supports just the understanding of what inquiry is. Now this definition up here is the definition of inquiry that IMSA uses, but you can see here that there are 4 different pieces of inquiry skills: planning, investigating, analyzing, and communication. And these are all things that we have done during 3-act math tasks. Under planning, we have asked questions and we've made predictions. We did estimating. Investigation. Act 2 was all about gathering information, making observations, and using tools. And those tools Don't have to be tangible tools. Remember, tools are strategies as well. Area models, arrays, standard algorithms, repeated addition, all of those are tools to solving. In terms of analysis, identifying relationships, evaluating the information. Do we think this could be correct? I asked you to refer back to the predictions and the estimations that you made. Do we think this could be a correct answer? Is this reasonable? And then of course, sharing and thinking about where we go beyond here. So this is also a great way to promote inquiry. Real world applications and inquiry go hand in hand. Inquiry is what we want students doing out in the real world. So it's easy to make that connection. All right, we're gonna go back and take a look at what happened in each of the acts, and then I'm gonna show you a video of this being done in a kindergarten classroom. So you can see how students, even at the youngest grade levels, are able to engage in this process. So first one is Act 1, and what we're really looking for here is we're engaging kids in the problem. We're engaging the students in the problem. The first thing that they do is they start off with observations and questions. What do you notice and what do you wonder? Now, you may have noticed that some of the noticings and some of the wonderings were not math-based. However, I acknowledge all of them. And if I were doing this in a classroom, I would do that as well. You'll always have the kids that will be like, oh, I noticed he's wearing a watch. I noticed his arms were really hairy. I noticed like blah, 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 blah. And sometimes it's funny, sometimes it has nothing to do with that, what you're actually after. But that's okay, because the more you do these, the better the students become in recognizing that you can make mathematical observations and that certain questions can be answered with mathematics. And that's really what we're going after here. We acknowledge all of them, but we know that we're really after those questions that can be answered in math, with mathematics. Then we have a main question. Now, again, you have a question as the instructor in the back of your mind that you really want to get students to. 9.5 times out of 10, the student population asks that question the most. However, you always have the option as the teacher to let the students pick one of the questions and go after it. They can investigate their own question, or you can direct it by saying, we're going to start with this question. If we have additional time, we can tackle the others. Also, a lot of times the questions are answered in Act 2 when they get information, but then we want to have them estimate. And I talked to you about Goldilocks guessing. We want to make sure that students are making that low estimate, that high estimate, and then that number part. And I'd really encourage you to build that into a lot of the different things that you do in your math classroom, because estimates can be done by anyone. And by repeated exposure, you just get better and better and better at it. And then when your young students get to middle school and get to high school, they are better sense makers and they understand what is reasonable and what is not reasonable. Okay. In Act 2, now the goal is for students to consider what they need. So again, when we look at that traditional worksheet, 9 times out of 10, the information that you need is included in there somewhere. We want students to ask questions to get what they need. Sometimes students will ask questions that they can figure out for themselves. My suggestion to you is do what I think is the most valuable, and that is just to be less helpful. You don't have to give your kids everything. If they can find out an answer to themselves, there is no reason for you to tell them. If they don't need the answer, the information to solve the problem, sometimes you can give them what they're asking for, because there's nothing wrong with weeding out what is important information, what is not important information. So something for you to think about there. And then this is where they solve it. This is also a great time if the students require instruction of some point, like direct instruction or a review or some new information, this is a good time to include that. We ask the question a lot, when do you do like the instruction for a 3-act math task? And my advice would do it now. Now students have a context that is necessary for. You can't solve the answer without knowing this. So that is a motivator for them, but it also gives them a context in which to wrap this around. And finally, in Act 3, you get your solution. The blocks or the rectangles that you see on the right-hand side of your page, this is an example of a student page. So if you were doing this in your classroom, this is what a student, and this is for like a 3rd through 5th grader. There is a different student page for a kindergartner through 2nd grader that I will share and show you what that looks like. But this is where students can keep track of their work. So in Act 3, they get the solution, but it is not the end. Once you get an answer, it's not the end of the mathematical investigation. Now we can talk about, do we think that answer is correct? How do we know? Is there something we need to go back and double check? And also, what can happen next? What could I do with this? Okay. So I want to show you what this looks like in a kindergarten classroom. And this is the most adorable video ever with all these little kindergartners doing some great mathematics. One of the great math resources that I reference quite a lot is, educator is Graham Fletcher. Graham Fletcher does a lot of kindergarten through 5th grade math PD. He has some wonderful resources and really focuses on number sense. But this is an example of him in a kindergarten classroom in October. So these are very young kindergartners, just to give you an idea. And this is what they're exploring as an Act 1. Okay, it's called the Candyman. I'm gonna play this. It is a little bit longer, but I do think it's valuable just to see how even the youngest kids are asking questions and making observations. And he does a great job modeling as a teacher how to handle all of that.
So how are we all doing? Are we doing okay?
Yeah.
So
It'll clear up in a second.
I want to show you this video, and I'm going to show it to you 2 times. I'm going to show it to you 2 times. Ready? So here's the first time. And the first time, I don't want you to talk to your partner. What I'd like for you to do is take what you see and put it inside your mind. So like think about it. What do you notice when you watch this video? Ready? Here we go. Good job. I'm going to show it to you one more time. All right, here we go. All right, what I'd like for you to do right now is talk to the person that's next to you. What did you notice? Go ahead. All right. Bring it back to me now. Here we go. Who would like to share something that they noticed? What did you notice?
Some money.
You noticed some money. I love it. Okay, so some money. What else? Yes, sir. What did you notice?
Candy.
You noticed candy. What type of candy?
Circle tabs.
Circle tab. I think they're called. They are. Is that chickle tabs? Circle tabs? Okay, so we noticed some candy. Candy. What else did we notice? Yes, ma'am.
We noticed that you had slapped it out.
Oh, so that's my hand. Okay. I'm just going to put down Mr. F for Fletcher. That's Mr. Fletcher's hand. All right? Good, good. I like that notice. What did you notice?
I noticed it was a tooth.
It looked like a
Teeth.
teeth. Okay, so it looks like we might have seen some teeth.
No, tooth.
A tooth. Okay. A tooth. All right. What else? What else did we notice there? What else?
We saw you turn the handle so it will make the penny go in, and then the candy comes out of it.
Oh, so you saw me turn the handle,
And then you pick the candy out.
and when I took the candy out, where did I keep the candy?
In here.
And candy.
Right, I'm going to fast forward it a little bit to see what they are wondering. Let me see if I can.
All right, bring it back to Mr. Fletcher. Who has a question about what you just saw right there? Who has a question? Like when you look at that video and you see that Mr. Fletcher took some candy out of that machine and he's holding the candy in his hand like this, what question might you have?
Reading. It was sour and it was like square.
So you saw that the candy was squares, so that might be something that we could add to what we saw. So we're looking for a question now. What might you wonder?
But it was different.
It was different colors. What was different colors? So you noticed that the candy was different colors. So I'm going to write down that you're wondering about colors. Colors. What do you wonder about?
I wonder how the money got in.
How did the money get in there? I love it. Okay, so how did the money get in there? Get in where?
The machine.
How did the money get in the machine? All right. Question mark. All right. What do you wonder?
It was kind of like an oval, and it looked like an oval, but when you put it in the room, it looks like a square. And then when it came out, you had to stick it under here, take it out, and hold it.
And I held it like this. Okay, so I held the candy in my hand when I pulled it out. What did you notice? I mean, what did you wonder? Sorry, what did you wonder? What's a question that you have?
It's different colors, and it looks hard and sour.
And it what? What did you say?
And it looks hard and sour.
It looks hard and sour. Okay, nice. What do you wonder?
I think if we broke it in half, if you gave somebody one, if you share with somebody, there'll be 9.
There'll be 9? So you think there's 9 candies in there? You think there's 9 candies in my hand?
It's a whole lot in there.
It's not just one candy in my hand? How many candies do you think are in my hand?
1,
Just one candy is in my hand?
5.
You think 5 candies is in my hand?
All right, so he continues on, and the question obviously is how many candies does he have in his hand? Now with a kindergarten classroom, a lot of times, as you saw, they're noticing and they're wonderings get very interchanged. They're working on how to develop questions, and in that grade level, it does take some prompting, which is absolutely okay. We're at that grade level, we're again helping students create their own questions. So 3-act math tests aren't always just about the math. It's also about that engaging in developing those inquiry skills. So to show you kind of where this went, in Act 2, students were given this information. They're again solving how many candies are in his hand. He had four orange, 2 yellow, 0 pinks, 2 reds, and 2 whites. And they were given this illustration and they were asked to, using this information, how many candies was he holding in his hand. And I want to show you, this is what the student page looks like for a kindergartner, and it is very open. All they were asked to do is to draw out this problem, and they were given the freedom of determining how they wanted to do that. You can see in the top left-hand corner, there's a box there, again, for their estimating. Even at kindergarten, we want students to estimate, how many do you think that was? You can see students drew out the candies by color using rectangles, and then they individually counted. And Some of them use numerals to show. They didn't need to draw those out, and they ended up with a solution. So 3 different kind of ways that we could expect a kindergartner to do this. Even if I was in preschool, depending on where my students were at, I think that this is something that we could work on. We work on being able to draw out quantities, and just taking that next step of composing them and putting them all together, I think could be done at a very early grade level. This is an example then of another student who was interested. And what was cool about his is he drew the 4 orange, the 2 reds, I think it was, the 2 yellows. And then, but he has a quantity, a final answer of 10. And what's neat about this is when you give students these sheets and you ask them to explain their reasoning, they have really cool explanations. Whoops.
Tell me what you got here.
1, 2, 3, 4 oranges and 1, 2 reds, 1, 2 yellows and the white. The rest of it is white. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Whoa, so you can't see the white, but they're there?
Yes.
I love it. So Mac, what does the number 10 look like if you were going to write that down?
A 1 and a 0.
Did you guess 10?
Yes.
Oh, right on, dude.
So he kind of took it to the next level, which I thought was interesting, but a great opportunity for kids to explain. And then in Act 3, he goes ahead and he shows the solution to that.
All right, here we go. So I'm going to show you what's in Mr. Fletcher's hand. Ready? Here we go. And we'll see how we did. Were we able to predict how many candies were in Mr. Fletcher's hand? I'll stop it at the very end and we're going to count them, okay?
But even that's in a ray. And it's moving the spot where that's it. It's one. I know it one. Ooh, somebody ripped them.
All right, let's take a look. Let's go ahead and count these. Let's go ahead and count these candies for me. So I see, what color is this one right here?
Red.
So we have
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Are there any candies left over?
Yeah! Right behind that one.
Where?
But that.
What color? Behind which one?
I know. It's another light.
Oh, you know what that is?
Light.
Look at this one.
Yeah.
What's that?
Ring.
It's my ring. That's my ring right there. You see how it's
So they went through and they were able to count those candies and then compare them to the work that they did. And in most cases, the kids did a great job. I thought it was really funny how they also pulled out his ring because, again, they're kindergartners. They're great. They see lots of things that we wouldn't. And just an example of what this looks like at a early grade level. So how do you get started developing not only 3-act math tasks, where do you find them, but the skills needed to do them well, which includes estimation, solving problems in multiple ways, talking about mathematics. The first one that I always recommend is Estimation 180. These are just, this website has a collection of pictures that students just estimate. So in this one, it would be how many diapers are in that box or in that package. And you can throw these up. I know that math talks are important parts of many classroom routines, and that's just an easy one to throw up an image and say, how many do you think? And there are always answers for those on that website. Open Middle is another great one, which has become very popular the last few years. And these are problems where students enter numbers in to try to accomplish a challenge of some sort. So this one is place numbers 1 through 9 in the boxes to create a true statement. Each number can only be created once. So this is really encouraging risk-taking to help students kind of develop some of those mathematical skills. The other one that I really, really like, and I've given this example several times now today, especially for my early childhood and K2 teachers, is which one doesn't belong. So if you see those 3 images there, which one doesn't belong is created by Christopher Danielson, who is a great math educator as well. And the only job here that students have is to pick out one of the images. So if I'm looking at perhaps the dominoes, and say which of those 4 do not belong, the top left, top right, bottom left, bottom right. And what we're doing here is we're simply asking students to think of mathematical relationships in their head, look for patterns, identify one that doesn't fit that pattern, and then talk about it. And this is great too, to show students that there are multiple ways to arrive at an answer, but also that sometimes mathematics has multiple answers. And it's a good way to have them talk about it. So for example, I could say the bottom left does not belong because it has a naked piece to that domino. I could say the top left doesn't belong because it's the only one when I add them together equals an even number. So just a great piece to integrate into a math talk. I want to give you this website right here. This is like the holy grail of 3-act tasks. This is an entire site full of 3-act tasks lessons. So if you look up Graham Fletcher, he has a tab on his website for 3-act tasks, and these are all ready to roll. So you just download the videos. You do not need to create your own. They're all here. They are by standard, kindergarten through I think 6th grade maybe, or 5th grade. They talk about what the big idea is, and then the question that is of interest. So all of these are here, plus he references some other resources at the bottom for higher grade levels or other elementary 3-act task resources. And just to show you kind of what these are, so here's some great K2 ones that work on sharing quantities of 20, adding and subtracting within 20, adding and subtracting within 100, and then working with quarters and wholes. So starting to think about fractions in that geometry piece. And then for my 3rd through 5th grade teachers, here is some examples for you. The naughty rope looks at multiplication and division within 100. The measurement and data one, the example I pulled out is building arrays within 100. They take those place value blocks and see how many of them fit into that rectangle. The one down at the bottom left is disgusting. It is how many hot dogs can he eat? It is the hot dog eating championship one. Multiplication and division within 100. And then of course there is an area with unit fractions. So really all over the spectrum here in terms of what you could have your students explore. Any questions before we kind of wrap up? We have a couple minutes that I can, yes, the resources in the presentation to download. So I'm going to show you that here in a second. Here's the link if you want to download it using the link, or you can go back to the page. But all the resources that I have used are in the download. Okay. So if I take you back to the page or to the website, let's see, where's my website? Okay. Here is your IMSAtute day. You will go to download session materials, and that will open up for you the page where you can download everything. And on this page, yeah, you can download this and it'll kind of go through everything that you saw here.